All right, so we are going to look at adding and subtracting rational functions. So what we're going to do is start by refreshing our minds with adding fractions. So if I notice if I'm adding 2/9 and 4/9, I have 2 parts out of 9 and 4 parts out of 9. So in adding those, I just add the numerators. 2 plus 4 is 6, and my denominator is 9. Now I can reduce 6/9 because I know that 3 divides evenly into both. So if I divide 6 divided by 3, that's 2, and 9 divided by 3 is 3. So my final answer would be 2/3. Now, for B, I need to add 3/10 and 7/15. Now, what I do to add 3/10 and 7/15 is find my least common denominator of 10 and 15. So if I think of multiples of 10 and 15, 10, 20, 30, and then multiples of 10 were 10, 20, 30, multiples of 15 were 15, 30, I can see that my least common denominator is 30. So I'm going to rewrite those with a denominator of 30. So what would I multiply 10 by to turn it into 30? Well, that's 3. So I'm going to multiply the numerator and the denominator by 3. So 3 times 3 gives me 9. And then switching over to the other fraction, what do I multiply 15 by to make it into 30? Well, I multiply by 2. So 7 times 2 is 14. And when I add 9 plus 14, I get 23 out of 30. And then lastly, if I'm adding 4x plus 2 over 5x plus 6x plus 3 over 5x, my denominator is going to be 5x. And then I'm just going to add the numerators. So if I add the x terms, 4x plus 6x, that gives me 10x. And then add the constant terms, 2 plus 3 gives me 5. So to explain my process, just find a common denominator, or find the least common denominator. So I'm going to find the LCD. Then add. So now what I would like for you to do is do problem number 1 on your assignments, A, B, C, and D, where you are actually factoring polynomials and simplifying them to find common factors. So now we're going to take our example here with rational equations. So just a couple quick rational equation questions. What would be my vertical asymptote for 3 over x plus 1? Did you get x equals -1? Because -1 plus 1 is 0. And then my vertical asymptote for 2 over 3x, I got x equals 0 because if I plug in 0 for x, 3 times 0 is 0. So in going back to adding these, let's find the least common denominator. Now, this has a denominator of x plus 1, and this has a denominator of 3x. So I can actually just multiply both to get my least common denominators. So we have 3x times x plus 1 is my LCD. So what I'm going to do here in the numerator and denominator of 3 over x plus 1 is just multiply both by 3x. So I'm going to go 3x times 3 over 3x, and I'm going to put parentheses around x plus 1. And then if my denominator is 3x, I need to multiply the numerator and denominator by x plus 1. So 2 times x plus 1 over 3x times x plus 1. So I'm going to keep the denominator the same here and write that as 3x times x plus 1. And in the numerator, I'm just going to simplify both pieces. So 3x times 3 is going to give me 9x plus, distributing 2x plus 1, I'm going to add 2x plus 2. So now as I add that, 9x plus 2x is 11x plus 2 over 3x times x plus 1. So now what I would like for you to do is complete problem number 2 on your assignment, just parts 2A and 2B. Notice the directions say, what is the least common denominator for each pair of expressions? So now for example A, add the rational expressions and write the sum as a single rational expression. So first what I'm going to do is find the least common denominator. So what I'm going to do is just kind of check. I have an x plus 1 in both. And then in the first expression, I have an x minus 2. So I know from both of them, I need an x plus 1. And then from the first one, I need an x minus 2. And then from the second one, I need an x minus 1. Oops, and I wrote x minus 2. Let me just write that out, x minus 1. So in the first one, I'm going to multiply the numerator and denominator by x minus 1. So I have x minus 1 times x minus 1 divided by x plus 1 times x minus 2 times x minus 1. And then for the second one, I have x plus 1 and I have x minus 1, but I need an x minus 2. So I'm going to take the x minus 2 and multiply it by x. And then my denominator is going to be x plus 1 times x minus 2 times x minus 1. And then for a rational expression, I'm going to leave the bottom in factored form. So we're going to have x plus 1 times x minus 2 times x minus 1. And then in the numerator, I'm going to simplify and put it in standard form. So x times x is going to make x squared. And then I'm going to have minus 1x minus another x, so minus 2x. And then negative 1 times negative 1, I'm going to add 1. And then I still have to distribute my x to x minus 2. So that's going to be x squared minus 2x. So I'm going to add x squared minus 2x. Then I'm going to chain this down and combine my terms. So I have x squared plus x squared, which is 2x squared. And then negative 2x minus 2 more x would be minus 4x. And then plus 1. All over x plus 1 times x minus 2 times x minus 1. And it's okay to leave one of the expressions in standard form and another one in factored form. So now what I would like for you to do is do problem number 3, parts A, B, C, and D. And now for our last example, we're going to write the difference as a single rational expression. So we have x plus 2 over x minus 3 times x plus 4 minus 5 over x plus 1. So we're going to look for our least common denominator. And I have x minus 3 in this one and another x plus 4. So that's going to have to be in both. And then I have x plus 1 in the other one. So I'm going to also have to have x plus 1. Now, in looking at the first expression, I'm going to have to multiply the numerator and the denominator by x plus 1. So I'm going to write x plus 2 and then multiply by x plus 1. And then my denominator is going to be x minus 3 times x plus 4, and then times x plus 1. And then I'm going to subtract. I need to multiply the other expression by x minus 3 times x plus 4. So I'm going to have 5 times x minus 3 times x plus 4. And then divide that by x minus 3 times x plus 4 times x plus 1. So my denominator here is going to equal x minus 3 times x plus 4 times x plus 1. And now I'm going to expand. So x squared plus 1x plus 2x. So we have x squared plus 3x. And then plus 2 times 1, so plus 2. And then here, I'm going to distribute first and then multiply by 5. So x squared plus 4x minus 3x. So plus 5 times x squared. And then plus 4x minus 3x would just be plus x, and then minus 12. And then I'm going to distribute that kind of up here, just so that I see that. I'm going to have 5x squared plus 5x, and then minus 60. And then I'm going to combine my terms. So x squared plus 5x squared is going to give me in the numerator 6x squared. And then 3x plus my 5x, I have plus 8x. And then when I add my 2 and subtract 60, I'm going to add 58. And then that's over x minus 3 times x plus 4 times x plus 1. Also, my apologies, I made a minor math error, so let me just fix it. First, I was minusing here, so I need to subtract here, which would make here minus 5x squared. And instead of plus 5x, this would be minus 5x. And instead of minus 60, I would add 60. So let me just scratch this out. And if I have x squared minus 5x squared, that would make in the numerator negative 4x squared. And then also, if I have 3x minus 5x, I would subtract 2x. And then if I keep going here and I have positive 2 plus 60, I would add 62. And then divide by x minus 3 times x plus 4 times x plus 1. And obviously with this amount of algebra work, it's easy to make a small math error. So make sure that you can compare your answers with your classmates and discuss if you can find a math error for any of those. And then if you could do the back problems, number 4, A, B, C, and D.